Hi everyone. Now it's 6:59. Let's wait for 1 minute. I am Anu. I am doing PhD from University of Hyderabad. Also a PMR of scholar. Can you introduce yourself since we are only 3-4 members?
Hi, this is Ashish here. I have done my master's from Central University of Punjab, Bathinda,
Oh,
specialization in computational and theoretical chemistry.
okay. I also did my masters from Central University, Punjab.
Oh,
Yeah. Okay. Hello Ritesh. Hi Abhimanyu. Can you just introduce yourself? Oh, okay. Okay. Now it's 7 o'clock. We can start our session. So, today basically we are going to discuss some for 3 or 4 questions. नीलाद्री सर को बोलो माइक ऑफ करने के लिए. So we are going to discuss some 3 or 4 questions from GATE Chemistry 2020. Okay. So I'll start presenting now. Oh, Abhimanyu. I am a student of MSc Chemistry. Okay. Okay. Whether slides are visible?
yes, ma'am.
Okay. So the first question we will be discussing is from GATE Chemistry 2020, question number 11. Okay. Among the following species, the one has pentagonal shape is atomic number of oxygen, fluorine, sulfur, iodine and xenon are given and 4 options are XeOF4, IF5, SF5 minus, XeF5 minus. So in order to solve such a question, we should have an idea about VSEPR theory. VSEPR means valence shell electron pair repulsion theory. This theory is very easy, in which we are just assuming, like, we know that any atom have electron clouds surrounding it, right? So these electron clouds will repel each other. So all the atoms will try to stay as far as possible. This is the basic concept of valence shell electron pair repulsion theory. For example, let's assume that we have a central atom and then we have, 1 minute, somebody wants to join, I guess. Okay. Okay. So for the one who have recently joined, I'll just tell you the question we are going to discuss here is GATE Chemistry 2020 question number 11, where we are going to find shape of different molecule based on valence shell electron pair repulsion theory. So as we discussed earlier, this is just a very easy theory based on how the electron cloud repulsion, because of electron cloud repulsion, how the atoms will try to stay as far as possible, and this will lead to a geometry and thus a shape. Okay. So now we are discussing like a central atom we have, for example. Okay. And this central atom is attached to two different atoms. So let it be 2 hydrogen. For example, I am just telling let it be hydrogen. Okay. So this hydrogen also have electron clouds surrounding it and it will repel each other. So what it will do? It will try to stay as far as possible. So around the central atom we have 360 degree, right? So if two atoms are trying to stay as far as possible means it will stay 360 by 2, 180 degrees Celsius each. So one will be this side and one will be this side, and this will have a linear geometry. An example is carbon dioxide, where carbon will be central atom and both oxygen will be staying in linear geometry. So based on this we can, like with our imagination itself, we can go for many molecules, we can assume the shape, but for some molecules like XeOF4 which is given in the question, it is little bit tricky, right? So for getting shapes of such structures, we have a simple theory where we will just count the total number of electron pairs. Let us see how to count the total number of electron pairs. From a simple example we will start. BF3. Uh, in BF3, our first job is to find the central atom, which is boron. Boron we know has 5 valence electrons. One more person is joining. I'll just accept him. Okay. So let's start with BF3, and the first job we have is to find the central atom, and in BF3 it is boron. In boron, electronic configuration is 1s2, 2s2, 2p1. There are 3 valence shell electrons. Now we can go into side atom. Fluorine. Fluorine is under halogen group, and it needs 1 electron to complete its octet. So there are 3 fluorine atom and it will give a total of 3. So in BF3, the total number of electrons will be 3 from boron and 1 from each fluorine atom, giving total 3. That will be 6. And hence total number of electron pairs or total bonds formed will be 6 by 2, that equal to 3. In between, if you have any doubt, you can just ask. No problem, you can unmute yourself and ask. Okay. In between explanation itself, you can ask. No need of waiting till the question is completely explained or not. Okay. So from the table above, we have seen if we are getting total number of electron pairs is 3, the hybridization is sp2, geometry is trigonal planar, and shape depends upon the number of lone pairs. Since in BF3 there are no lone pair, shape will be same as geometry and it will be trigonal planar. Okay, so in order to solve any question related to this where geometry or shape is asked, we just need to know the first table, whichever slide I have shown. Okay. Admit. So if you know this table, you can solve all the problems and it will come for 2 marks generally, and you can solve it. It will be very easy marks to obtain. So now let us go into our question. Now we know how to calculate number of electron pair. We can go into our question. The first one is XeOF4. Okay. So here which one is the central atom? It is xenon, and xenon has 8 valence electron. Now how many side atoms it has? 4 fluorine atom and 1 oxygen atom. Fluorine we know it is halogen atom and it needs 1 more electron to complete its octet. Similarly, oxygen needs 2 more electron to complete its octet. So therefore, the total number of electrons in XeOF4 will be 8 from xenon, 2 from oxygen and 4 from fluorine, totally giving 14. Now the number of electron pairs will be 7. But we should not think that the total number of electron pair is 7, so hence geometry will be pentagonal bipyramidal. No, because oxygen we know is a atom which will form double bond. Hence Since it will form double bond, it will, instead of 7, it will have only 6 position. So the geometry will be octahedral. And since there are 5 side atom, one place will be vacant and the shape will be square bipyramidal. Like octahedral means we have a square, and above one atom will be there, below one atom can be there. But since only 5 side atoms are there, we have one vacant space and it will be a lone pair. Hence, the shape will be square pyramidal. The next one is IF5. Okay. In this, which one is central atom? Anybody? Hello?
Iodine.
Iodine. Okay. Iodine has 7 valence electron. And how many side atoms are there?
5.
5.
5. Okay, so the total number of electrons on the molecule IF5 will be 7 plus 5 equal to 12. And hence the total electron pairs will be 6. 6 means what will be the geometry?
Octahedral.
Octahedral. And since there are 5 positions, 5 fluorine, 1 position will be vacant, right? So 1 position will be lone pair and hence shape will be
Square pyramidal.
square pyramidal. Correct. Good. IF5. So the next option given is SF5 minus. Okay. Here also the same method we are following, where we will find the central atom sulfur, which is having 6 valence electron, and then side atom fluorine, which there are 5 fluorine atoms, require 5 electron. And one thing we need to know is that if in a particular molecule is given, if there is a negative charge, we should add 1 to the total electron count, and if there is a positive charge, we should subtract 1 from the total electron count. I think one more person is joining. 1 minute, I'll admit him. Okay. So in this molecule there is one negative charge is there. So it means we have to add 1 electron. So the total number of electrons will be 6 from sulfur, 5 from 5 fluorine atom, 1 from negative charge and 12. So the total electron pairs is 6, geometry octahedral, 1 lone pair, and shape will be square pyramidal. So in point of gate, no. Actually the thing is many people know how to solve. The basic thing is we should know how to handle the time. Time is the most important thing. So if a complex like SF5 minus is given, in mind itself we should be able to calculate sulfur, central atom, have 6 valence electron. Fluorine, 1 each, 5. 6 plus 5 plus 1 negative charge, 1. 6 plus 5 plus 1, 12. That means 12 by 2, 6. Total electron pairs is 6. Like that we should be able to calculate. I think one more person is joining. Sorry. Okay. So like this, in mind itself we should be able to calculate 12. So within 1 minute we are getting the answer. So the time we are able to manage. Like that, if we get 12, 12 by 2, 6. 5 positions, 6 means octahedral, 5 positions are there, 1 will be lone pair, square pyramidal. Like that, even without taking a pen and paper, we should be able to do. That means you have to practice questions regularly. That is the important thing in order to solve, in order to qualify gate. Okay. So the last one is XCF5 minus. I think you guys can tell me which one is central atom. Xenon. How many valence electron it has?
Z.
Sorry?
8.
8. And how many side atoms it has?
5 fluorine.
5. So total electron count, can you count?
14.
14. Correct. 8 plus 5 from fluorine plus 1 from negative 14. See, you calculated within seconds. So you can answer the question very easily. 14 means how many bond pair? 7. Right? And 7 among which only 5 position is occupied, and that means what will be its shape? can you guess? Like geometry is pentagonal bipyramidal, right? In that 2 lone pairs are there. So the shape will be pentagonal. I will tell you how. Just imagine a pentagon. Okay? Pentagon we have. This is a pentagon. Okay? And in this bipyramidal means above a pentagon, one bond pair or lone pair will be there. Below also one bond pair or lone pair will be there. That is pentagonal bipyramidal shape. Geometry. Okay. And if lone pair is there, now you can ask that why lone pair is here, why lone pair is not here. Anybody knows the answer? So, okay.
To avoid repulsion.
Correct. To avoid repulsion, we have a simple rule that lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. So, if we consider this both position, no, this both position are staying at as far as possible. The angle is 180 degree. Okay. Since the lone pair repulsion is greater, they will try to stay as far as possible and thus will be at axial position. This is called as axial position and this is called as equatorial position. So hence the shape is pentagonal. Okay. If instead of 2 lone pair, if 1 lone pair is there, what will be the shape?
Please repeat.
If like in this particular case we have 2 lone pairs, no. Instead of 2 lone pairs, if we just have 1 lone pair, one more bond pair is there, then what will be the shape?
Square pyramidal.
No, this is pentagon, no?
Okay.
Pentagonal pyramid.
Hexagon then.
Hexagon then I will tell you. Okay. Like first what we found, the total number of electron pairs, right? That is 7. Okay. 7 means we have a total of 7 means we will have a geometry of pentagonal bipyramidal. In this, now we have to find how many lone pairs are there. If in this 2 lone pairs are there, that means this bipyramid is there. No, you can imagine it in your head. One pentagon is there, bipyramid is there. One atom is here, one atom is here. Okay. If 2 lone pairs are there, these atoms are not there. So this is just as a pentagon. Okay. I don't know who are asking. Somebody told square, no? Who was it? You have any doubt or it is not clear, you can ask me.
Ma'am, please repeat one more time.
Which one, like, should I start? Which one should I start? Or
you were saying one lone pair case, no? That one.
Do you know how to find out the number of lone pairs?
Yes, ma'am, I got it. But in last minute, you were saying na, that in last case, only one lone pair is present. And then what will be the shape that we want to ask?
Okay. You got till geometry is pentagonal bipyramidal, no?
Yes.
Okay. If geometry is pentagonal bipyramidal, that much we got. Now, the difference between geometry and shape is in the number of lone pairs. Okay?
Okay.
If x instead of XeF5, I am telling that one more atom is there, like XeF6. For example, it's just an example, okay?
Yes, XeF6.
Then we got till this much is same. Geometry equal to pentagonal bipyramidal. Till that much is same. For example, then we have only one lone pair, right?
Yes.
If only one lone pair is there, then from pentagonal bipyramidal, only one place will be lone pair. All the other place will be filled with atoms.
Yes.
Then the shape will be what? Pentagonal pyramidal.
Okay, I got it.
You got it, no?
Yes.
Okay, fine. So the question was, among the 4, which one has pentagonal shape? And the answer is XeF5 minus, the last one which we have derived. Okay. Anybody has any doubt, you can ask me. No problem. I will explain 2 times, 3 times. No problem at all. Because this is a session where you can interact. Because normally in YouTube channels, like it will be recorded. No, you can't ask questions. So here, this is a platform where you can ask any question. I am also not a teacher. I am also a PhD scholar. So in my knowledge, whatever I know, I will tell you. Or you can mail me also. I'll give you my mail ID also. Don't worry, you can ask any question. No need of any hesitation. I also don't know many things, so don't worry, you can ask any question. I'll explain it to you in my knowledge 2 times, 3 times. No problem. Is it clear?
Yes, ma'am.
Yes.
For everyone, is it clear?
Yes, ma'am.
Sure? No,
Yes,
you
ma'am.
guys don't have any doubt? It's sure.
Yes, ma'am.
If I give you any question, you will be able to do it, right?
We'll try, ma'am.
Yeah, good.
We will try, ma'am.
Yeah, so in all gate 2020, gate 2019, I think in most of gate there will be at least one question from this VSEPR theory, right? To find out geometry and to find out the shape, and it will carry 1 mark or 2 mark. So you try to solve question taking gate before before previous year's question. This is 2020 question. You can try for 2021, 2019. Every paper, I am sure that most of the papers will have 1 or 2 questions. So you try solving that. If you have any doubt, you can ask me, but try solving that and don't leave any question. You know the concept now, and you will get, I am sure you will be able to get. Just practice on solving question, and that will save you time, because time is most important, and then you will be able to solve it. Okay.
Okay, ma'am.
Okay, so this question is over. I think we can move on to next question. Slides are visible, no? Okay. So this is a question from GATE Chemistry 2020, question number 36. The correct combination of L1 and L2 Mn H minus, NO minus, MeCH2 minus and Cu that will satisfy the 18 electron rule for both metal centers in the following neutral molecule is. So in the question they are asking what is L1 and what is L2, and 4 options are given that will satisfy 18 electron rule. So, in order to find that out, we should know what is 18 electron rule, right? So, 18 electron rule says that consider we have a central transition metal atom. Any metal atom will have an ns orbital, np orbital and n-1 d orbital. So in s orbital, we know maximum 2 electrons it can carry, and p orbital it can carry 6 electrons, and in d orbital it can carry 10 electrons. Totally 2 plus 6 plus 10, that equal to 18 electrons. So if any metal atom fulfill this criteria having 18 electrons, that is considered to be stable, and if any metal compounds does not have 18 electrons, that is considered to be reactive. So how to find out which metal atom in a particular complex follows 18 electron rule or not? This can be found out by counting the total electron. How to count it? The equation is very simple. For getting the total electron count, we can add the valence electron of central transition metal plus electrons donated by ligands. So the first term, valence electrons of central transition metal. For example, if in a complex given, iron is the central transition metal. How many valence electron iron has? 8. So it can be obtained easily directly from the electronic configuration. So this part is easy. First part is easy, where the valence electron of central transition metal has to be found. That is easy. Now the second part, electron donated by ligands. That we will see how to count. And I'll tell you one thing, like when you are writing gate exam and all, no, before starting your exam, you will get some time, 5-10 minutes to sit. They will give you paper, pen, and all those things. So that time only you just write the atoms, method, electronic configuration, the periodic tables simply. So whenever such kind of questions will come, no, you need not want to think which is of which group, which is of how many valence electron. No need of thinking. You already have it. Just write. So it will save time. So all the things which will save you time, you have to think and do it accordingly. Okay. So now let us go on to the next portion where we have to count electrons donated by ligands. First, let us study this by taking some example. The first one is ammonia. Ammonia, okay, we have learned in the last question itself how to find the geometry and shape. So let us try to find it out here now. Okay, ammonia in nitrogen is the central atom, right? Nitrogen has how many electrons? Valence electrons?
5.
5, right. And hydrogen, how many? 1. So 3 hydrogen, 3. So 5 plus 3, 8. 8 by 2, 4. That means 4. 4 means what will be its geometry? Tetrahedral.
Tetrahedral.
Yeah. And it has 1 lone pair. So what will be its shape? Pyramidal.
Pyramid.
Correct. So the shape is pyramidal. So from the earlier question we know how to find the shape. So by seeing this only we can understand the nitrogen has only 2 electrons which is available. So it can donate 2 electrons. So it is a 2 electron donor. It is as simple as that. So ammonia is a 2 electron donor. One thing is done. Now next look for carbonyl. So what about carbonyl? Carbon has total 4 valence electron, among which 2 is bonded with oxygen. So it has 2 more electrons which can be donated to the metal. So hence carbonyl is also a 2 electron donor. Now we can see hydrogen or any sigma bond. So we know how a sigma bond is formed. It is formed from 1 electron by each atom, right? 1 electron from this hydrogen and 1 electron from this hydrogen. So any sigma bond is consisted of 2 electrons. So if this is connected to a metal, this means that a sigma bond is also a 2 electron donor. So the next one thing is that many ligands which are connected at terminal or bridging will contribute different number of electrons, may contribute different number of electrons, that we will see. But neutral ligands and sigma bonds always contribute same whether it is terminal or bridging position. Now the one important ligand is hydrogen. You don't get confused with this minus sign. There are 2 methods to count the total number of electrons. One is ionic and one is neutral method. I think it is better, easy to go with neutral methods, which will be 1 minute. Somebody has to join, I think. Okay. Okay. So we will go with neutral method. That is easy and we won't get confused. In neutral methods, don't think of any charge. That will be easy for you. And just think of H. What is the configuration of H? It is 1s1. It has only 1 electron. So whether H will be in terminal position or bridging position or any position, it can donate only 1 electron and hence it is a 1 electron donor. The next one, Cl. This is an important one because if you understand this Cl, you will understand how some ligands will contribute different electrode in terminal and bridging position. So Cl, we know it has 7 valence electron, right? 1, 2, 3, 4, 5, 6, 7. 7 valence electron. So if it has to form a bond with metal, what it will do? First, it will try to complete its octet, right? Whichever be the atom, first what it needs, it wants to complete its octet first. So when it is making a bond with metal, it will make one single bond where it is getting 1 electron and it is sharing 1 electron, like that. So Cl in terminal position will have only, it act as a one electron donor. Now its octet is completed, it is satisfied. Now it has no problem in sharing other electron. So now if one more metal comes, it will give its other lone pair of electron. So thus becoming a 3 electron donor. So chlorine in terminal position will act only as a 1 electron donor, whereas in bridging position it will act as a 3 electron donor. Okay, and the sign for bridging is mu, and if two metals are attached it is 2, and if one more metal is attached, for example here, that means it will give one more of its lone pair and it will act as a 5 electron donor. Okay, now we know the basics of 18 electron rule, how to count total electron count and all. Now we can solve the question. This was the complex given to us, right? So here we have to find the total electron count, in which first we have to find the valence electrons of ruthenium, central transition metal ruthenium. Ruthenium has 8 valence electrons. Okay, and it is attached to carbonyl. We saw earlier that carbonyl is a 2 electron donor. So we write 2, and this is cyclopentadienyl, which is a 5 electron donor, and it also has one metal-metal bond. Metal-metal bond is formed by one electron from this ruthenium and one from this. So each ruthenium has one electron. Therefore, the total electron count will be 8 plus 2 plus 5 plus 1, that equal to 16. So in the question, it is told that the complex follows 18 electron rule. So in order to fulfill that criteria, each ruthenium needs 2 more electron. Each is now having 16 electron. So each requires 2 more electron. That means both L1 and L2 are 2 electron donors. Now what is our quest? From the 4 options given, we just have to find out which one is a 2 electron donor. Okay. So the first option given was H. We already see, so that it is a 1 electron donor. The second one is NO minus. Nitrogen, I told you we can go with neutral method, which will be very easy and you won't make any mistake. So NO, the structure, N has total 5 valence electron, among which 2 will be bonded with the oxygen and it has 3 electron, right? And now how many electrons nitrogen has? 1, 2, 3, 4, 5, 6, 7, right? 7 electrons. So nitrogen requires one more electron. So it will share only one electron so that it will get one electron. First, any atom will try to complete its own octet, right? So in this case, this act only as a 1 electron donor. The next one is MECH2 minus. So Me means CH3, CH. Then this carbon has 4 valence electron, among which one is with CH3, one is bonded with H, and 2 more electrons are left. Hence, these 2 electrons can participate in bonding. This will act as a 2 electron donor. And the other option is carbonyl, which we already discussed, can also act as a 2 electron donor. You guys have any doubt? You can ask how this came and all.
Ma'am, MECH2 minus.
MECH2 minus. Okay, this, don't get confused with 2 minus. This actually means that this will bond with metal, but it has a negative charge. So that will be much more confusing for you. So you ignore the negative charge, right? Ignore it. Just consider it as a neutral molecule. So see, MECH2 minus. 2 minus ignore. Carbon has 4 valence electron, right?
Yes, ma'am.
Okay. Among which one is bonded with Me, that is CH3. One is bonded with hydrogen, right?
Yes, ma'am.
Remaining how much electron are there? 2.
2 electrons.
So this 2 electron, it will bond with metal.
Okay, ma'am.
Okay. So how the by bonding like this, what will happen to carbon? It already has 2, 4, 6. If it bond, it will get 8. So carbon is also satisfied, and this 2 electron, it can donate to metal. So hence it acts as 2 electron donor.
And we can try it in every case of ligand. where it has negative charge or positive charge?
Yeah, I think it can be applied. Yeah, it can be applied.
Ma'am, even in positive charge also?
Even in positive charge cases like NO plus and all, it is little bit different. Like NO plus is bent structure and it acts as 3 electron donor. It is little, I will write maybe NO plus. This is NO, right? NO. Okay. NO plus means this electron is already given. This electron is already given to metal like that. Okay, NO plus means. So this 2 electron also it can donate and it will act as 3 electron donor. That is a different case.
Ma'am, how 3 electron donor? Like we will count also what it is already bonded with M. One from there and 2 electron from there.
It is already bonded with M. It can bond with another M also.
Okay, so we will consider it as 3 electron donor.
3 electron donor. So this is a special case. NO plus NO minus. We always get confused and we.
मैं उद्यम कर रहा हूँ तो मुझे उस चीज का अनुभव ठीक ठाक है, मैनेजमेंट का अनुभव अच्छा खासा है।
Excuse me.
एक सवाल ये पूछा गया है कि
Hello.
Yes, ma'am. Ma'am, 3 electron donor.
Yeah, so this one is little bit tricky one. This can ask in many questions. So NO plus and NO minus, you should have an idea. NO minus will donate 1 electron and NO plus is actually bent structure. Like here it will donate and like this it will donate. Actually, speaking of shape, so this will be bent and it will act as a 3 electron donor. So this is a thing that you should remember because it will help you in many questions. This will be asked.
Ma'am, actually I have doubt in this list of ligands now. So how can I ask? But list is not ready where I have doubt.
You can ask me in mail. I will send you mail. My mail ID. You can ask me how many electrons because there are so many ligands. I also can't cover all the ligands and you also cannot ask about all the ligands. So whatever ligands you have doubt, like many of the ligands are very common, like HCO, NH3, H2O, many ligands are very common and that you will get anywhere. But if you have any doubt like how NO plus became 3 electron low or in some places we will get confused, no? Anything like that you can ask me in my mail. I'll give you my mail ID. You ask me there and I'll reply you. Maximum I'll reply, don't worry, because I also don't know. I am also learning. So if you ask me any doubt, I'll also learn. If I don't know, I'll mail you back. Don't worry.
I have 5 to 7 ligands in doubt. I will ask.
Okay. No worries. You can ask. Okay. You can ask me in my mail. Okay. So now the question was which can be among the 4 option L1 and L2, and we saw the L1 and L2 should be 2 electron donors and the 2 electron donors among the 4 options given are MeCH2 minus and CO. So the correct option is C. You can visit this classes. I am giving you YouTube link here. I can share you presentation or not. I'll see or take screenshot or something, and you can visit NPTEL. There are many classes. You can visit that because in this session, we will be mostly focusing upon how to solve questions rather than these basics. So I think it's better for basics to be clear. You can see that classes, and to solve the questions you can see these classes. Okay. Is there any doubt, or if you can mail me also, or you can put in chat if you have any difficulties in asking. I'll see chat also. Okay, till now nothing is there. If you have any difficulties, you can ask me in chat also or in mail also. No problem. Okay. I hope that these two questions are clear. So I'll go to the next question. So this is question from GATE Chemistry 2020, question number 48. In this, among the following, the total number of species having nido structure is. They have given total 6-7 compounds, and among which we have to find the one having nido structures. Okay, we will go step by step. The first thing we have to know in this, I am not going to explain what is closo, nido and all. That I will give you the class link last. You can see that. I will just explain you how to solve the problems given. So for solving the problem, you should know this table. This is very important. If you know this table, you can solve any question related to this structure of clusters. So this is basically Wade's rule. We should know Wade's rule or polyhedral skeletal electron pair theory. Hello? Somebody is asking something? It's not clear. You can put in chat box also if you have any doubt. Anybody wants to ask something? Fine, no? Okay, then I'll proceed. Okay, this table is very important. Like if we have given a borane structure, borane means the compounds which contain boron and hydrogen. Carborane, along with boron and hydrogen, carbon will be there, or any other organometallic compounds. We can find out what is the structure: supercloso, hypercloso, closo, nido, arachno, hyperchelado. Anything we can find by simply by calculating the skeletal electron pairs. How to calculate this, that I will discuss with you in the following slides, and you have to remember this formulas also. BnHn2 plus n minus 1 supercloso. This thing you have to remember. With that only you can solve any problems related to this topic. Okay. So the first one is B12H12 2 minus. This is very easy if we know this. If we know this table, right? BnHn2 minus. BnHn2 minus. So from the table itself, we can tell directly it is closo structure. Okay. So other proper way to solve it, we can solve this also by calculating the skeletal electron pairs, by calculating the total number of electrons, where we calculate boron. Boron we know have 3 valence electron. Hydrogen we know have 1 valence electron. And the total electron count will be, there are 12 boron and 12 hydrogen. So 12 into 3 for 12 boron plus 12 into 1 for 12 hydrogen, and 2 minus means we have to add 2. That will give a total of 50. And each BH is made up of 2 electrons. We know each BH has 1 sigma bond. 1 sigma bond is consisted of 2 electrons, one from boron and one from hydrogen. Okay, and since there are 12 BH, B12H12, it means that there are 12 BH. 12 BH means 12 into 2, that will give 24. So 24 electron is participating in the formation of this cluster. The skeletal electron pair will be 50 minus 24. Sorry, I made a mistake. 24 electrons are participating in the formation of BH bond. Total there are 50 electrons. 24 electrons are participating in formation of BH bond, and the remaining electrons will participate in the cluster formation. So 50 minus 24, that equal to 26 electrons will participate in the cluster formation. 26 by 2 equal to 30 will give skeletal electron pair. This falls under n plus 1 category, because what is n here? N is 12. 12 plus 1 will give 13 and 13 means it is closer. This is there in here. See, BnHn2 minus n plus 1 closer. Okay. So we can directly solve it like this. This will be easy if you know the formula because no need of calculation, right? So that will save you time. You can directly get the answer closer. So no need of somebody asking something. Okay, somebody admit. Okay. The first one is over. So let's go to Ni5CO12 2 minus. Here also the just one formula you have to remember. The formula is number of skeletal electron pairs is total electron count minus 12n divided by 2, where n is the number of metal. Now let us find each term. First the total electron count. How we will calculate total electron count? That we saw here earlier. First nickel. Nickel, the number of valence electron for nickel is 10. 10 into 5 nickel atom is there. 10 into 5 plus carbonyl. We already saw in the last question that carbonyl is a 2 electron donor. Right. So each carbonyl will give 2 electron into 12 carbonyls are there. Plus 2 negative charge is there. So plus 2 giving 76. 76 is the total electron count. Here we know n equal to 5, right? So total electron count minus 12n will be 76 minus 12 into 5, that will be equal to 16. Now skeletal electron pair is 16 by 2 equal to 8. So 8 means n plus 3. N plus 3 falls under arachnum. Okay? Is there any doubt is there or is it clear? Hello? Is it clear?
Yes, ma'am.
Okay. So if it is clear, now let's move on to the next one. C2B9H11 2 minus. Here carbon, boron and hydrogen is there. That means it's a carbonyl. In this case, we need to know one concept called as iso-Lobel analogy. We know carbon has 4 valence electron. Okay. Now each BH, boron has 3 and hydrogen has 1. So BH also has total of 4 electron. So in such cases, we tell that carbon is iso-Lobel to BH. So we can replace each carbon in this cluster with a BH. Because then we can directly fit into the formula and we can directly get the answer. Okay. So in this cluster, we are replacing carbon with BH. So C2 means BH twice, B9, H11, 2 minus, which also can be written as here 2B is there, here 2, here 9B, total 11 boron plus 2 plus 11, 13 hydrogen, 2 minus, which also can be written as B11, H11, H2, 2 minus. Why I am writing this is because we have to get this in this formula, in such kind of formula, so that we can directly get into the cluster structure. So if for example consider that I am removing 2H plus. Okay. If I am removing the excess H plus, like 2H plus, 2 negative charge will come. That means this 2 minus will become 4 minus here. And the formula will become B11, H11, 4 minus. That means Bn, Hn, 4 minus. Bn, Hn, 4 minus will comes under needle. Okay. In this is there any doubt? Is it clear?
Yes, ma'am.
Okay. It's if you have any doubt with this, you can ask me. If it's clear, then we will proceed. Okay. The next one is RH6CO16. So in this case also we can proceed using this way, where the number of skeletal electron pairs equal to total electron count minus 12n by 2. Okay. the total electron count will be 9 into 6. 9 is the valence number of valence electron on rhodium into 6 plus 2 into 16, that equal to 86. Here n equal to 6 and therefore total electron count minus 12 n will be 86 minus 12 into 6, that will be 14. Therefore the skeletal electron pair is 7. So this means it is having n plus 1 structure. N is 6 and total is 7. So it is following n plus 1, that is 7. That means it comes under closed loop category. Okay. Here we saw now n plus 1 is closed loop. The next one is OS6CO20. This is also same method. Okay. So here somebody tell me how many valence electrons are there in osmium. You know the periodic table. 8. Right. Good.
8.
Good. Now 8 into 6 osmium is there plus 2 into 20 equal to 88. And what is n here?
6.
6. Good. So total electron count minus 12n will be 88 minus 12 into 6 will be equal to 16. Skeletal electron pair will be 16 by 2, that equal to 8, and this falls under n plus 2, that equal to nido. The next one is B5H11. Now we know almost how to calculate all type of compound. We have seen how to calculate where metal and carbonyl atoms are given, carbonyl molecules are given. We know how to calculate carbonyl with isolobal analogy, and we know how to calculate boron. So this should be easy. B5H11, we have to take it into this formula. Okay. B5H11, somebody is joining. Okay, fine. Okay, B5H11, we have to take it into this formula, BnHn formula. So how we can write B5H5 dot H6, similar to what we have written here. Now we are removing, assume that we are removing 6H plus, and it will give an overall minus 6 minus charge on this complex, and this will fall under arachno category. This can be easily interpreted if you know the first table. Okay, this is fine. Good.
Yes, ma'am.
You are able to follow it, no?
Yes.
Okay.
Yes, ma'am.
Okay, fine. And the last one is B6H10. So can you tell me how we will solve this? How can we write this in this way?
Ma'am, B6H6H4.
Correct. Now if we remove 4H plus, what charge will come?
4 minus.
4 minus. Good. B6H6 4 minus. That means it is under nido category. So good. So there are totally 3 which falls under nido, and the question was the total number of species having nido structure is. So the answer is 3, and the 3 are C2, B9, H11 2 minus, OS6, CO20 and B6H10. For further reference, you can visit classes of Professor M.S. Balakrishna, NPTEL reference, and the YouTube link is given. You have any doubt regarding this? You can ask me. This is a very common question in almost all gate problem like VSC PR. This borane compound is an important structure where they will ask the structure of the compound, and it will be so direct. They will give you the compound. Like recently, I think 2018 paper only, I saw one. Just they have given B12 H12 2 minus direct formula, and they have asked the structure. So it's 1 mark, and it is easily you can get if you know this table. You just need to know this table, and you can easily, that mark is very easy, and you don't have to waste any time on that. Just directly with that you can get that answer. Okay. So you can take a screenshot of this. This is very important, and if you know this, the answer will be clear. Okay, you have any doubt regarding this question, please let me know. The whole we have explained all the clusters, but you have any doubt, you tell me. Is it clear? All compounds are clear, or anything else is there in to explain? Yes or no?
Ma'am, all clear.
All clear, no? No problem, right? Okay, I'll give you my mail ID also. You can note it down, so that in future for any doubt you can ask me. We have discussed today 3 questions. One is from VSEPR, one from organometallic compounds, and one from borane cluster structure, which is related to weights theory. Weights theory, VSEPR, and organometallic 18 electron rule. So you should know all the 3: VSEPR, weights rule, 18 electron rule, and with that, each gate paper, each gate exam, there will be at least one question. You can get minimum 2 to 4 marks, I am expecting. So if you have any doubt, you ask me anything from any question so far we discussed, you can ask me and I will clear it out. Because now it is already, I think, 7:55. If I take one more question, it will take another 20 minutes. So that much time we don't have. So you have any doubt, you can ask me now regarding this. And somebody, I don't remember who, asked me about ligands. Who was that? You can mail me, I'll give you my mail ID. You can write it down. 1919 Shika. It was Shika.
Yes, ma'am. Yes,
Okay.
ma'am.
You make your list and then you mail me. Okay.
Okay.
My mail ID is 1919
Okay.
CH
Ma'am, repeat again.
19 CH
CH.
PH. I will write here. That will be better for everyone. One nine CHPH 14 at uohyd.ac.in. It's clear, no?
Yes, ma'am.
Okay. You note it down. For any further doubt, you can ask me. So you guys are all preparing for GATE and NET also.
Yes, ma'am.
NET also?
Yes,
Yes,
ma'am.
ma'am.
Okay, in NET also these topics are important. Whatever we discussed today, no, these topics are important. And this kind of questions what we discussed later regarding weights rule, that can come in 4 marks also in NET. Okay, so it is very important. You have taken screenshot of all the tables that I have shown, or should I show it again?
Ma'am, I have taken already.
You have taken, right? Okay.
Thank you so much for sharing the email.
It's fine, no problem. You can ask me doubt at any time. Okay. So anything else is left? You want to discuss anything regarding GATE, NET, or anything else? You can tell me. Hi, Ravindra Kumawat. You have raised your hand. You want to ask something?
Yes, ma'am.
Okay, carry on.
Ma'am, you discuss only previous year question on this platform, or you take regular classes for important chapters?
Actually, in this platform, we will discuss only questions. For regular classes like basics and theory, you can visit YouTube, in which NPTEL classes are there from renowned professors of IIT, central universities and all. You can visit them. They have all classes of most of the topics, and here we will, in this platform, whichever platform, whoever will take class, everybody will be dealing with previous year's question. Because even if we know theory, no, where we lack is solving question, because we don't have the basic, like the timing. the timing is important. So if we solve as many questions as possible within the time, then we will be able to clear the gate or net, whatever. Otherwise, even if we know the basics, most of the, I think that personally everybody knows chemistry. The problem is with managing time. So that's why we are here helping, like how to solve, how to manage the time, how to easily get into the answer. And then if you have any doubt regarding the previous year question, you can ask us directly, because we are there as a mediator. We also are learning and you also will be learning. So like that, as a live interaction section. Normally the classes will be like recorded one. So here you can ask any question freely as possible. That's why. So we will be discussing only questions here.
Yes, ma'am. Thank you, ma'am.
Thank you. Is there anything else? Anybody else want to share something? Okay.
No, ma'am. Thank you, ma'am.
Okay. Then it's fine. Have a good night. Okay. Bye.
Good night, ma'am.
Bye, ma'am. Thank you, ma'am.